me just check something. Yeah, okay. Close the register. So last week we finished up to question 6 of the multiple choice, and yeah, we finished up to question 6 of the multiple choice, so we'll just continue to the end of the multiple choice, and after that there's a surprise, which I'm sure you guys will like. So let's do that. I will share my screen quickly. Share the whole screen? Yeah, I'll probably share the whole screen. Okay, let me minimize that so that we can actually see the question. Okay, so question 7, you guys can see my screen, correct? Let me open up chat as well, just in case you have any questions while we go through this. Can everyone see clearly? Are we all good? Cool. So the question states, we're just continuing from question 7, just so that we can polish this off before we get onto some other stuff. So you're creating a class named Square that is derived from the Polygon class. The Polygon class has the following code: class polygon public virtual void draw. Cool. So it's an empty method, but we can see that it does have like an empty body, right? It does have the body. All right. The draw method in the Square class should provide new functionality, but also hide the Polygon class implementation of the draw method. Which code segment should you use to accomplish this? So you can see all the questions on page 61 of your textbook, if I'm correct. So yeah, do fill them in as we go through them there. There they provide you with this entire code block, but the basic difference is just the single word that comes after public in each code block, right? So it's either override, new, virtual, or static. Static at the bottom here. It's a bit covered by the Google Slides thing. Okay, so do we have any ideas initially? Like, can you guys give me even just one of them that we can rule out from what you know? Like, we've got A, override, B, new. How would we? So are you answering A, Dapper? You're answering that. Okay, that's a fairly good answer. And we'll go through. So what I would want you immediately to see, guys, we can discuss each question in quite a lot of detail. So C, virtual, D, static. Okay, both of these options are not valid. Okay, so that's the first thing I want you guys to be able to see. Static is referring to something totally different, right? It's not referring to how we supersede functionality or hide functionality. Okay, so static is, I want you to see that that's something different. Virtual, we wouldn't use in the derived class, right? Virtual, we would not use in the derived class. We use it to declare the method in the base class, right? We said here, public virtual void draw. So our two options are override and new. And I'm going to go over to Rex Tester and we'll see what exactly what exactly the difference is. But if you could already see that it was either A or B, then you're in a really good spot. And actually, even if you leaned A, I would say that you're in a good spot still. But we do need to be very careful about what the difference between these two things are. Okay, so let's just discuss this a little bit in Rex Tester. We'll set up the exact code example that they have there in the question, and we'll discuss each possibility, or at least the two feasible possibilities. So override and new, and just compare them. Okay, so what's happening? They've created this class, right? So they've got a class polygon. Okay, and we don't care about what else polygon has. All the multiple choice tells us to care about is the singular method. So it'll be public some word void draw. Okay, And here they gave us an empty body in the question, right? It was just like, just two curly brackets, right? Like that. We can see that in the question. They just have these two curly brackets. They're totally empty. Okay, so that's sort of what their method looks like. I'm going to do something just to show you the difference between override and new. All right. So what I'm going to do is I'm going to say inside the polygon implementation of the draw method, what I'm going to say is that it goes console.writeLine, and it just prints out polygon version. Okay, polygon. Or let's say it prints out draw polygon. Okay, so just instead of it being blank, it prints out draw polygon, and they say virtual here. Virtual allows us to declare a body here. All right. Cool. So that was the basic side of their example. And then they tell us you also want a square class that must provide new functionality for this draw method. Okay. And we sort of know what they're going for there, right? We've seen a similar example to this. So what it would look like is something like class square. Okay. Class square, and this square class is going to inherit from polygon, right? We've seen this exactly before, actually. Okay, and what they're telling us is we want to provide new functionality for this draw method. Okay, interesting. So, well, you have seen new highlighted in the question now, but we'll but I want you to see the exact difference between new and override. Okay. So what we've definitely seen before is saying something like public override void draw, right? We've seen this before. And then instead of printing out draw polygon, so you can see if I call the draw method in the polygon class, it prints out draw polygon full stop, right? We can see that it goes console.writeLine draw polygon full stop. We also we know that if we use this override keyword, we could say console.writeLine draw square, right? Draw square. Now what I want to show you, obviously if I create a square here, so I say square sqr equals new square, right? That's how we create a square object, an object of type square, right? And then I say square.draw, right? So that's calling this draw method over here. Right, square.draw calls the draw method inside square. We agree, right? If I just minimize this and I actually go ahead and run this, so I'm going to click run, you can see it prints out draw square. Draw square. You guys see that? Okay. So if I read what they say here, at least the first little bit, let's read the question again. They say the draw method in the square class should provide new functionality. Okay, new functionality, and it does that currently, right? It does definitely provide new functionality currently, right? It's the original draw method says draw polygon, this one says draw square. That's new. Okay, but then it says, but also hide the polygon class implementation of the draw method. It says, but also hide the polygon class implementation of the draw method. So you see I've highlighted new here because the answer is B, new. But why is it new and not override? We've just seen that override can provide this new functionality, right? But why is it new and not override? Well, it has to do with the second bit here. It says hide the polygon class implementation. Hide it. Now, does override hide it? When you think of the word hide, what does that mean? Does it mean overwrite? No, it's subtly different, right? So what I want to show you is, let me remind you of this idea quickly before I use it to show this to you. Do you guys remember this is keyword? If I say, so our object here of type square is called SQR, right? You remember if I go SQR, so square, our square object, is square. If I print this out, so if I put it in a console.readLine, you remember that will print out true, right? You remember that. or if you don't, now's a good time to see it. Okay, that's what the word is does. If the thing on the left is the same type as the thing on the right, then it will print out true. Okay, that's what is does. So what I want to show you is to say, all right, since we know square is square, okay, we know that this prints out true. What you've also seen before is if I say square is polygon, right? So currently we go square inherits from polygon. If I say SQR is polygon, this will print out true because all squares are polygons. Okay. Sorry, just muting my phone there. Square is polygon. Okay. So that also prints out true. So I hope that this doesn't worry you, but what I'm going to say is polygon square equals new square. Now, hopefully it might look surprising. We have seen something like this before, but it might look surprising to some of you. But hopefully you can see that because all square inherits from polygon, right? So all squares are polygons. So saying polygon square, okay, so it's a polygon, equals new square, this is totally fine because squares are polygons. Okay. Now what I want you to see if I print out, so you see it's polygon square. Okay, if I run this, it still prints out draw square. Okay. Now if you didn't understand a lot of that, you're actually still okay. The main point that you must get here is that the word, it's just the difference between the word override and new. Okay, as you've just seen, the word override, and it sounds like what it does, okay? It overrides, it supersedes, it replaces, overwrites, okay? It overwrites the original functionality. So the original version of the draw method was called draw, it printed out draw polygon. When we override it inside our square class, okay, when we're creating an object of type square, when we override it inside our square class, it's replaced. Okay, it's not hidden, it's totally replaced by the new functionality. Okay. However, the word new, okay, it doesn't overwrite the original functionality, it just hides it away. Okay, so I can show you, if I say square square equals new square, and we use the word new to create the draw method, and I run this, it still prints out draw square. Okay, exactly like the word override would. Okay, you see it prints out draw square, exactly like the word override would. But if I say polygon square equals new square, what happens? It says draw polygon. Okay, so the new keyword didn't overwrite it, it hid the original implementation. So when we read this question, it says the draw method in the square class should provide new functionality. Okay, so either override or new could do that, right? Either override or new could do that bit, could provide the new functionality. But then it says, but also hide the polygon class implementation. Okay, so that also hide tells us that it must be new and not override. Okay. So hopefully, are you guys comfortable with that idea? It's basically just the subtle difference between the word new and override is what's being tested here. Okay, if they say supersede, overwrite, permanently replace, something like that, then we would use the word override. But if they say hide, then we would use the word new. Okay, it's a subtle difference, but this is why I think this section is actually quite difficult. It's because there's all of these words and they're also subtly different. Okay. Cool. Hold on. I must get my textbook from my room quickly. 1 second. Okay, yeah. So I think question 8 is a bit mean. All right. Let me read it out to you guys quickly. So it's on page 62, page 62, and it's about this I comparable is what it's about. Right. We've seen iComparable before. Okay, so the question is just asking, we have a rectangle with a length and width. How do we implement compare to? Okay, so again, we have done exactly this example, in fact, exactly this. So I don't want to spend too much time on it because I do want to get to the next thing. But I will just show you. So if I go to Roosevelt High iComparable, it's actually what we did last week. We did literally exactly the question they're asking. They have a subtle difference though. Okay, quite subtle. Cool. So I do want to just discuss this. We did discuss this in quite a lot of detail last week though, so hopefully this wouldn't take too long. If one of you reads through question 8, maybe give your thoughts. They do compare things in a slightly strange way. So that's what I want to discuss quickly. So last week when we learnt about iComparable, we also compared the area of two rectangles, right? We got this dot area and rect dot area. Hopefully you guys remember this from last week. And we discussed that there were 3 possibilities. This rectangle could be before the other rectangle in the order, it could be equal to the other rectangle in the order, or it could be after the other rectangle in the order, okay, based on their area. So if this dot area was less than rect dot area, we returned -1, right? Any negative number would work. We returned -1. That would show that this rectangle was before the other rectangle in the order, okay? This dot area greater than rect dot area, we would return 1. So any positive integer would show that this rectangle was after the other rectangle in the order. And otherwise we returned 0 to show that the rectangles were equal in the order. Okay. What I want to show you is the correct option from your book there on page 62, question 8. All right. What I want to show you is the correct answer. Okay. So they compare things slightly differently. All right. So what they say is they calculate the difference between the two areas. Okay. So the area method returns a double. Correct? You see public double area. So if I say double difference, we'll use diff for short, equals this dot area minus rect dot area. Okay, and you remember rect refers to the other rectangle. Okay. Now, if I say if diff equals 0. Okay. So what I want you guys to tell me, and I want you guys to tell me this. You can see this little maybe equation that we have on this line. All right. Difference equals this dot area minus rect dot area. If difference is 0, what would that mean about the areas of our rectangles? So we've got this dot area, that's the area of our one rectangle. Rect dot area is the area of our other rectangle. We subtract them from each other to get the difference. If that difference is 0, what would that mean? Okay, yeah, we would have to return 0. But study why. What would it mean about the rectangle's areas? What would it mean? When do we return 0? Dap, do you not get it? Nope. Okay. Let's think about it this way. If I subtract 2 numbers from each other, okay, so I have a number, any number, pick any number, subtract it from another number. So say number 1 minus number 2. If the answer is 0, what would that mean about the 2 numbers? What would that mean exactly, right? Do you understand, Dapper, like why that would mean they're equal? Right, let's picture it with 2 normal numbers. If I say int x equals 7 and int y equals 8, or also 7, let's say. Or actually, we can leave it blank. Okay. If I say x minus y, look, focus. Let's see. X minus y. Okay, so We've got int x equals 7, y equals something. It just doesn't equal, and it doesn't equal anything. This is quite simple though. So then you should like it. Okay, so if we say x minus y, so 7 minus something, okay, I want the answer to be 0. What does y have to be? If I want the answer to that to be 0, what would y have to be? Yeah, exactly. It would have to be 7, right? And that's the only possible answer. That's the only thing it could possibly be. The only way that the answer to this would be 0 is if both of the numbers are the same. Right? X would have to equal y if x minus y equals 0. And you can see it with any number, right? Like if this was 20, if x was 20, y is just nothing. I don't know what y is yet. For x minus y to be 0, y would have to be 20, right? Then x minus y will be 0. And that's the only possibility. Okay. So it's basically saying no two different numbers are equal. It's almost like that kind of thing. Okay. All of the natural numbers will have different values to each other. Okay. If you like, something along those lines. There'll be some mathematical axiom for it. Okay, so we can see it'll be true for these two doubles as well, right? This dot area minus rect dot area. The only way, like that, axiom. You'll learn about them one day, I'm sure. Okay, so this dot area dot rect dot area. Okay, so the only way this could be 0, right, is if the two areas are equal. The area of this rectangle must equal the area of the other rectangle. Okay, that's the only way it could be equal. And if there's equal to 0, so that's what we check here. If difference is equal to 0, we need to return 0, right? And we can see this with some other things, right? Like I could say else if, okay, what if I say diff is greater than 0? Okay, so let's see this again, because it's a pretty interesting idea, so let's spend some time with it, okay? Int x equals 7, int y equals something, okay? I then say x minus y, okay? X minus y. If we say x minus y, like so, if that is greater than 0, what do I know? If that number, if x minus y, whatever we get from that, what do we know is, yeah, exactly. But even more general than that, Teddy, even more general than that, because what about 7.5, right? That if y was 7.5, like if these two things were doubles, then like, so what can we definitely guarantee? It would be 0.5 then. 0.5 is still greater than 0. So what could, yeah, exactly. Like, what if it was that? So what do we always know about these two numbers in the general case? If the difference of the two numbers is greater than 0, that means that the first one had to be, we must actually, we must be careful about this. Okay, so difference must be greater than 0. That would mean that the first number would have to be, what would it have to be? It would have to be smaller. No, careful, Taddy. Because look what's happening, right? If you say 7 minus 6, right, exactly. 7 minus 6, right, that would work. 7 minus 5 would also work. If they were doubles, we can make them doubles just to make it a little bit more general, right? If we said 7 minus 6.5, that would give us 0.5, right? The answer to this would be 0.5. 0.5 is greater than 0. Okay. So exactly, 6.9 would give us 0.1. That's great. It's greater than 0. 6.99999. Okay, so what we know about this, all right? If the difference of the two numbers, if this dot area minus rect dot area is greater than 0, okay? If this dot area minus rect dot area is greater than 0, that means that this dot area was larger than rect dot area. Okay. That would mean that this dot area was larger than rect dot area, which means that we can read through our little our comments here. If this rectangle is before the other one, return a negative number. If this rectangle is equal to the other one, return 0. If this rectangle is after the other one, return a positive number. Okay. The order that we're defining, the larger, we're going in ascending order. Okay, so the larger area has to go afterwards. Okay. So this would mean that this dot area was greater than rect dot area, which means we would have to return 1. And otherwise, in all other cases, we've checked. So if difference was 0, that would mean they're equal. If difference was greater than 0, that would mean that this is larger than that. If and in all other cases, what do we know? What do we know in every other case? It would mean that that is larger than this, which would mean we return -1. Okay, so it's a slightly different way of doing the exact same thing we did last week, basically, is to calculate the difference of the two rectangles. All right. Okay, so that was question 8. A bit silly, and I think question 9 is also a bit silly, but question 9 I do want you guys to get yourselves. Okay, so hopefully we're okay with this. This will pop up again though, so we'll have some more time to go through it. Hey, yeah, good one, Taddy. Yes, 8 is A. Yeah, 8 is A. Okay, it's not B. It's not B, and you can see that it's not B immediately. It says if diff equals 0, return 1. Okay, that's what it says, which means that if the rectangle's areas were equal, it would return 1. That's wrong, right? It was supposed to return 0. It's not C because they say if this equals target. They're comparing the objects. They're not comparing the area. And what does it even mean to compare objects? We can only compare numbers, right? So C is wrong and D is wrong for the exact same reason. They're comparing objects and not numbers, right? They say if this equals target. That's immediately wrong because you can't compare the objects. Okay, so it's A. So B, C, and D are all wrong. It's A. Okay, and we can see that A is correct. So question 8 was A. All right. This one is mean, and we will discuss. Okay, yeah, I also thought that this one was pretty mean. Although, actually, it should be pretty easy for you guys after our previous discussion, I think. Let me think. Did we cover what this as means? Oh, wait, no, we didn't. Okay, let me do this with you. Okay, so instead of doing D directly through the book, we're doing a coding example that will explain it to you. Okay. Because it's a keyword that you guys don't know exists yet, I think. Okay, but in general, this will be a good thing to learn, and then question 10, you guys should be able to get quite easily from what you've seen before. Okay. So what we're going to do, how should I set this up? We can do it quite simply, I think. Cool, so I'm just going to create a method, all right? So I'm going to say void, I'll say public static void. These are very cool emojis. Okay, so we've got a thing here. Right. I suppose it's even simpler than this. Let's not even get into this. Okay. So what I'm going to do, I'm going to create another our classic class rectangle. Okay. Our classic go-to class, and I'm just going to give it a length and a width just so that we know what it is. Okay. We've seen this before a gajillion times. Hopefully we don't have to discuss it again, right? That they have getters and setters so that they're accessible outside the class. So we've just created these two properties. also called data members, right? Properties, data members, fields, any kind of thing like that. You would think about like these. Okay, so we've got this class rectangle. All right, I'm not going to do anything special with it. We're not even going to give it a constructor. All right, it's just that. Okay, so what I want to show you guys is it's just a few things. Let me see. Can I do this? Will it allow me to do this? Because that might be very convenient for our purposes. Oh, it won't. Wait, let me see. Ooh, okay, that was my mistake. Let's see now. Okay, it does allow me to do it. Okay, cool. So let me remind you of just a few ideas quickly so that we can get through this. So if I say console.writeLine, O is rectangle. What will this print out, guys? So that's O. Rectangle O equals new rectangle. What will this print out? What will that print out, guys? Anyone know? If I say console.writeLine O is rectangle, what will that line print out? Do we remember what is does? True. Precisely. Good one. So you see it prints out true. Right? Now, if I say O is object, okay, it also prints out true, right? Object is a special word in C#, all right? You can see it's highlighted in purple because it recognizes it. All objects in C# are object, okay? They're all object. Okay, and it sort of makes sense. That's what we would call it, right? We've been calling these things objects forever. And it turns out C# also calls them objects. So that's great. Okay. Yeah, exactly. Rect, all the rects, all the dragons, all of the different objects that we've ever seen, Tadi, they're all also objects. Okay. They're enemies too. They're also rectangles. They're all of these other things as well. But any object in C# is also an object. Okay. That object keyword applies to it. It's not super technical, and you don't have to think about it too much. Okay, but it's just a nice keyword that they added. So what I want to show you is if I create a variable of type object, right? We know how to do that, right? If I create a variable, how we do it, remember early on in the course I told you all variables have two things, right? A type and a name, right? So we can create like int x, we can create string name, we can create rectangle rect1, right? All of those are variables. We could also create object obj or o, whatever. This is also a variable because object is just another type, okay? Or like a special type. Okay. So, and then we can also give it a value, all right? And the thing on the right, new rectangle, is a value. You're trying, yeah, ask questions. Feel free to ask questions, Dape. We can stop whenever. We do, although time is a bit of the essence, but it's totally chilled. Tring. I assume that's supposed to say trying. Cool. So, but you guys recognize this, right? This is how we say, yeah, it is. We might go a bit over time today, but it's totally fine. Don't worry about it. Don't worry about it. Okay, so we know how to create variables. That's fine. Okay, so object is just another data type. You don't have to think about it too much. Okay. Although, yeah, I appreciate that a lot of this stuff is quite challenging. So we can create variables like this. Remember, we've discussed this for long. All variables have a data type and a name, right? And they can also have a value, right? You put the value on the right. Notice that over the entire course, we've never deviated from this structure, right? Even when creating objects, like if I create an object in a normal way, rectangle, rect equals new rectangle, for example, this one we've seen a lot. Okay. When I create an object, I always follow this. We give it a data type. In this case, it's a class that we created, right? A class is just a nice way to create your own data type, basically. You're just creating your own new data type, if you think about it. So we can say rectangle rect. Okay, so we said rectangle, that was a data type, our own data type. Okay, we said rect, that's the name of our variable, right? It's just the variable name is rect. And then we say equals rectangle, basically. We have to say new as well, but we're saying new rectangle, that's just a value, right? It's just the value that we're assigning to the variable. Okay, so we've never deviated from the structure. And all I'm showing you is that you can change the data type of an object to object, like so. Okay, not too bad. Okay, so the shame getting threatened for correcting grammar. That's a common thing on the internet, though. Okay, let's go though. I do want to finish this. Okay, so you see, currently we're working with rect, right? If I say object rect equals new rectangle, you can see that if I say rect is, let me do it this way. I'll say rect. So object rect. If I say rect is rectangle, you can see it prints out true. Okay, it prints out true. You see, it, even though I created it as an object, it equals new rectangle. It's true. So it is held in the correct way. Okay, even though I made it of type object. Okay, but now if I want to work with it as a rectangle, right? Like what if something expects a rectangle? Okay. Like it'll work in some cases, or if I get an object that's not necessarily a rectangle. So if I get another object like triangle or something, and I say triangle is rectangle, that would be false. Okay, so I need a way to convert things that are rectangles into rectangles. Okay, and C# added a special word for this. The word is as. All right, as. Okay, so we've got this object O, and it's a rectangle, right? A new rectangle. Okay, and we can say, let's say I no longer want to save this in object O. I want to save it inside a rectangle object. So I would say rectangle R equals. No. We're now on question 9, Dapper. The answer to question 8 was A. Okay, so right, we've got rectangle R equals, and I'll just write out how you'll do this and then we'll discuss it. So we would say O as rectangle, like that. So yeah, and then we can get started on something new, which will maybe help just improve your confidence a bit. As long as you're, at least you've got the first 3 questions, and I would say refer back to the multiple choice a lot when we go through this next thing. Okay, but let's just finish question 9 and 10 quickly because we have spent quite a long time on this. Okay, so all right, object O equals new rectangle. Now, look, this line here, all this is doing, okay, is converting O from an object to a rectangle. Okay, and C# added this word as in particular, specifically to do this. Okay, so it's similar to the word is, all right? It's just saying, like, just read it as English. Rectangle R equals O. All right, that we know what that would mean, right? This kind of thing we've seen before. Rectangle R equals O. We're just saving something into something else, right? We know what the equal sign does. It takes the thing on the right and saves it in the thing on the left, right? If we just say, if we add this as rectangle, it's saying I don't want to save this as an object, right? You see it's currently object O. I want to see it as a rectangle. Okay, let me see if this works with other data types, and that might be a nice way of explaining it. Actually, no, because it won't look nice. So let's not do that. Okay. So, are you okay with this? This is just converting from one object to the other. And what I really want to tell you about this, because honestly, like the course, you know, our time has been thrown off a bit. But what I want to say is, when you see the word cast, all right, in any of these questions, it's A. The answer to question 8 was A. When you see these things in any of these questions, when you see the word cast, all right, note that down. When you see the word cast or invalid cast exception, okay, the answer is always the one that contains the word as. Okay, that's the hint I'll tell you. All right, the answer is always the one that contains the word as. That's how we convert between types. All right. Yeah. Basically, O is cast to type rectangle, and then R becomes O. Exactly. We save O in R. So it's almost like it's similar to how we use the word as in real life. Actually, we would say, I want to see the object O, but I want to see it as a rectangle. Okay, so currently it's an object. We can see that object O, but I want to see it as a rectangle. Okay, so that's what the word as is there for. That's how you should convert between different object types, okay? And you can see where this might be useful, right? If we have a polygon, and you know some of our polygons are triangles, some of our polygons are rectangles, and I'm given a polygon, right? You just give me a polygon. And let's say I want to calculate the area of the polygon, but I want to say length times breadth. For triangles, I couldn't say length times breadth. So I can always just say, I want to use this polygon, but I want to use it as a rectangle. Okay, and if that fails, then we would have to do something else. All right? But the idea is that this will allow you to view a general object like a polygon, but see it as a rectangle, okay, or see it as a triangle, or see it as anything else, as a square, for example. Okay, so that's what this word as is there for, just for casting between types is what we call it. But whenever you see the word cast, the answer is the one that has the word as in it. Simple rule. If you remember that rule, you'll get the answer on a multiple choice test. Okay. And one day, if you become a professional C# developer, you can go more in detail onto this weird little word that they added to their language. Okay. Yeah. Anyway, we can discuss it more if it causes trouble later. Okay, now on to question 10. So this is the last question, question 10. So the answer to 9 was B, right? Why is it B? Because B is the one that has this word as, right? O as rectangle. That's the answer to B. Okay, the others are wrong. We can see that C, they say O is rectangle, so that would return true or false, right? You wouldn't get a rectangle at the end, you would get a Boolean, right? And then these other ones would potentially have invalid cast exceptions. So that's why it's not A or D. Okay, but basically what you must remember about those questions is if you see the word cast, the answer is the one that contains the word as, right? Look for the word as, and that will be the answer to the multiple choice question. I know it's a horrible rote learning way to learn it, but some of the questions in section 2 we have to do that way because like if we go into too much detail, we'll be here all year. Okay, and coronavirus hasn't given us that luxury, unfortunately. Okay, let's go on to the last question. This one I do want to see. I want you guys to answer this one, actually. And I actually want you to do this in this way. All right? So I'm going to read through the question. I'll tell you one of the key things that we're thinking about. And then I want you to tell me like what the answer is. And I think a lot of you guys will be able to do this. So if we say you are writing code, again, the question looks intimidating. Okay, the question looks intimidating. But what I'm going to tell you to focus on is quite simple. and then you must just read through the multiple choice. Okay, just read through each of the 4 options and just tell me what you remember. Like, almost follow your gut, and then we'll discuss in more detail why this is true. Okay, so you are writing code to handle events in your program. You define a delegate named rectangle handler, like this. Public delegate void rectangle handler rectangle rect. Okay, we know what a delegate is. It's like a signature for a method, right? You also create a variable of the rectangle handler type as follows. Rectangle handler handler. Okay, this is basically an event. Okay, it's an event. We've got an event. Later in this program, you need to add a method named display area to the method invocation list of the handler variable. Complicated way of wording this, but what they're saying is that you want to add a method to your event. So if you remember when we did events and delegates in that YouTube video that maybe you had watched, or the lecture that you attended, we had this event, we had this concept of events, and we added a method called notify subs to our event. Okay, that's what they're doing here. They're adding a method. Yeah, exactly. The bell one as well. We added a bell to our event as well. We added notify subs and we added notify bells. Okay, I can actually, I'll show it to you at some point. Actually, you don't remember. All right. Well, at least maybe try to subtly think back to it. We had this method, we had this event. Ours was called uploaded. We had the uploaded event. Okay, and we would have said something like uploader.uploaded something. Okay, and then subs.notify subs. Yeah, exactly. That whole lecture, the events and delegates lecture. Okay, and there was one important idea that we focused on, but let's relax a little bit. Okay, so they're saying we want to add something to this list. Okay, add. Okay, they say later in this program you need to add. Okay, we know what that word add means. Yeah, it was a while ago. Okay, I notice how many times I've said the word add. Okay, anyway, so we said add. Yeah, exactly. The first assignment. Add. Yeah, exactly. Except with 2 Ds. And then we say the signature of the display area method matches the signature of the rectangle handler method. So that's cool. And then we say any code that you write should not affect any existing event handling code. Given this restriction, which of the following code should you write? Okay, guys, they give you 4 simple options. Okay, I'm going to write them out in Rex Tester. Okay, now bear the question in mind. Let me click on this. Okay, so let me do this. Okay, so I want to add something to my method invocation list. What will I do? Will I say handler equals new rectangle handler display area, right? That's option A. Would this add the display area method to my handler variable? Maybe. Let's look at the other options and then you guys can decide. Okay, we could say handler equals display area. Okay, would that add the display area to the handler method? Would it add it to it? I don't know, maybe. Would we say handler plus equals display area? Would that add the display area method to our event? Would that add a new subscriber to our event? Maybe. And then we could say handler minus equals display area. So those are the 4 options they give us to add a method to our event. Okay, option A, option B, option C, and option D. Okay, there are 2 ways out for you guys on this question. Both of them, if you trust your gut, they would get you through it. Okay, the 2 options are either think back to our events and delegates example. How did we add the notify subs method and the notify bells method to our event? How did we do it? Okay, interesting. How did we add the notify bells method and the notify subs method to our events? Okay, how did we add it? And the other way of thinking about this is to say, what does the word add mean? And how do we add in C#? Okay, so I want you guys to look at these a little bit and think of either one of those two things. Either think back to our events and delegates example, which was our first coding assignment. It was a lecture, I think, 3 weeks ago, sounds about right. Or think about what the word add means. Look at these different options. Which one would add to a list? Okay, you think A because of the new. Interesting. Okay, Kreflo is thinking C. All right. Let's just go back to this events and delegates example and see what's going on. Okay. Might be beneficial. Roosevelt High events and delegates. There it is. I'll open up this one. Okay, so looking at this, what do we think, guys? What was our event's name again? If we go check out our event, right here, look, we can see in the slides, they create rectangle, handler, handler, right? We also create our own event or thing. We say public event, and then we say uploaded handler, uploaded, okay? So we have uploaded, they have handler, okay? We have uploaded, they have a handler, okay? The method they want to add to their handler is called display area. The method we want to add to our handler is called notify. And the other method we want to add, we didn't add any other methods, I don't think. We didn't in this one yet. That was the assignment. I think I did that somewhere else. Okay, so we've got these methods. All right, we've got this notify method. Precisely. Look how we add the notify method to uploaded. Okay. Now there's quite a simple way to explain this, and so I'm gonna explain it in that way. All right. The answer is C. And if you remembered back to our events and delegates, I remember making quite a big deal about this plus equals here. Okay. Now, let me remind you, because the question itself is pretty, there was two ways out, okay? The first one was to say, think back to events and delegates and think about it, okay? The other way was to say, what does the word add mean, okay? Remember what our actual options were. Only one of them had a plus sign in it, right? And literally, guys, it would have been that simple, right? Because if you say handler plus equals display area, when I ask you how to add a thing to a list, whatever I'm asking you, when I use the word add, you're almost certainly going to be looking for a plus sign. Okay, guys. So that's one trick to remember. You're almost certainly going to be looking for that plus sign. Okay. So yeah, I think it's a bit strange, but that is an easy way to remember. Okay, we're thinking about the word add. Yeah, basically always in mathematics and just in life more broadly. Okay, when we use that word add, you're almost always going to be relating it to plus. Okay, and when I say almost always, I think for all of these questions, yeah, all of them. But let me show you why in more detail. Okay, so in our case, we're working with a list, right? Like we, in the case of events and delegates, we're working with a list, right? So we were adding the display area method, all right? So the list would have looked something like, there would have been area, maybe render, and then maybe display area, you know, like a bunch of methods. Okay, a bunch of methods, right? Like they would have had, let's say they would have had area and render. And they're asking, how do I add something onto the back of this list? I want to add on display area. So I want to make the list look like that. Okay. It previously looked like this. If you used the first example, you would be replacing the list with something that's not a list, right? So this is our handler list. Something like that. Okay, obviously this is just implicit, right? This isn't literally what it would look like. Okay, so if we said handler equals area render, if we use the first or second example, we would just end up with something like this, right? There's no longer even a list. If you just say handler equals display area, then this is what you would get at the end. There's no list. Okay, if you say minus equals, right? Like if I say, if we have this and I say minus equals display area, that doesn't even make sense. Okay. So the only option was plus equals. But what I want to show you is an even simpler way. Let me create a string. So I'm going to say string x equals do. Okay. Cool. So if I say console.writeLine, x, you're happy that'll print out do, right? You're happy that'll print out do. Everyone comfortable with that idea? Yeah. Cool. What I'm going to do now is say string y equals g. Okay. Yeah, we haven't changed x at all, right? We haven't changed x at all. So it'll still print out, this will still print out do. Okay. So what I want to do now is ask you a couple of questions. So let's look at A and D, or B and D first. Okay, I mean A is a little bit strange because they're changing types, so it's not A. But let's say, ooh, that's unfortunate. But I mean, you do have a schedule, right? So, cool. So if I say, let me say x equals y. What would this print out now, guys? If I say string x equals do, string y equals g, and then I say x equals y, and I print out x, what will this print out? G. You think it'll print out do, Dappe? How? You agree, so x initially is set to do. Then we say y equals g, right? We then say x equals y. So we take the thing on the right, which is y, and we save it in the thing on the left, which is x. Okay, so we take g and we make x g, right? So then when we print out x, it's no longer do, it's now g. That's what this line is doing. Okay. Do you understand? Cool. So, no, it's fine. Don't worry about it too much. Okay. What if I say this? If I say x equals x plus y, what would that print out, guys? Yeah, exactly. We just changed x to y. We're familiar with that. If I say x equals x plus y, okay, you think it'll print out dog? That's correct, yeah. And we know this from what the operators do, right? The equal sign will take the thing on the right, and save it in the thing on the left, right? So the thing on the right will just be x, which is do, plus g, right? Y, which is g. So this becomes dog, and then we're saying x equals dog, and when we print this out, it'll print out dog. That's correct. Okay. A shorter way of writing the same thing. If I say x plus equals y, what will this print out? What will that print out? Dog, still. Yeah, that's what plus equals means. All right. So you can see what this did is it added g onto the back of X. Okay, it didn't remove the D and the O. It just added G to the back, just like with our list, right? If we have a list that has a bunch of methods in it, right, like method 1, method 2, and we want to add the display area method. Yeah, exactly. We want to add the display area method to the back of this list. Right, well, yeah, Tadia takes the thing on the left, adds it to the thing on the right, and then saves it in the thing on the left. Right, so it's doing what a plus sign does and what an equal sign does. Right, because X equals Y would take the thing on the right and save it in the thing on the left. X plus Y, if I just say X plus Y on a line, right, just like that, nothing would happen, right? If I just said X plus Y, just that, right? If I just say X plus Y, nothing would happen on that line. Yeah, actually, yeah, Krefler, that's correct. It just concatenates the two strings. 100% correct. That is one way of saying it. Okay. But it also adds, right? Because it doesn't have to be strings, remember. Like I can make int x, I could say int x equals 7 and int y equals 6. Okay, change this to an int. If I say x plus equals y, right? If I say x plus equals y, then it will say 13. Okay, it will say 13. So guys, concatenates just means add on to the back. Okay, similar to what appends means. Okay, it's concatenates. It's just another way of saying it. All right, so don't worry too much. Okay, but the important thing to understand is it's the same with the list, right? If you have a list of two methods and you're adding something onto the back of this list, right? I want to add on to the back of this list. I want to add on display area. We use plus equals. Okay, cool. So the answer to question 10, guys, look in your books. What is the answer to question 10? Just so that you guys, there we go. Cool. And that would bring us to the end of section 2. All right. Sort of. There's one more thing we got to do. But that is technically the end of section 2. Okay. So, let me think about this. So what I want to do now is remember at the end of section 1 we did that mock test. You guys remember that? We did that mock test for section 1. And we've prepared one for section 2 as well. There's two ways we could go about today. Right, I'll let you guys choose. Either I can leave this mock test as the extra assignment, or we can just do it now and you guys can just finish it in the last little bit of today's lesson, and then we'll review it next week. What do you guys prefer? Do you have a vote on this, or you want to do it now? Awesome. Okay, let's do that then. Okay, so for those of you who are watching on YouTube, the mock test will be linked in the description of the video, and so you can just do it at home when you have time, and then we will review it next week. All right. So hold on, I'm gonna stop sharing my screen now. Okay, and I'll send this on the chat. Okay, I should post it on the WhatsApp now as well, hey? Oh yeah, 100%, Teddy, go ahead. What questions do you have about that? But yeah, for now, guys, open up the mock test and you can just go through the multiple choice. Ooh, Dape, you haven't been shown about the tourney, hey? It's like a Fortnite tournament, but you wouldn't have seen it because you weren't on the WhatsApp group. I'll resend it. Where was it? I'm not sure if it's still open. Is it really that soon? Yeah, June 27th, eh? There we go, it's posted on the Roosevelt group. Okay guys, so yeah, for the rest of this lecture we'll just do the Google Forms test, and then I'll link it in the description, and then for those of you watching on YouTube, you can go ahead and do it whenever you have time, and then we will review it in next week's lecture. Okay. Yeah, I also, for those of you watching on YouTube, I will also type in the description 2 hints for questions 13 and 14, and then there's also a thing to note about questions 7 and 11. All right. Cool, guys. So that's what we're doing now for the rest of this lecture. We can also take a quick break, I reckon. Let me stop recording, though, because the rest of this probably it won't be good for YouTube.